Hi, and welcome back to another SkyPortal how-to. In this how-to, we are going to be talking about SkyPortal extensions. And so the idea here is that while SkyPortal's baseline app has many features that you would need for doing astronomy data analysis, it's unsurprising that it is not sufficient for all. And for example, things like specific analyses or particular data sets, it may be appropriate to work with what we call a SkyPortal extension, which basically adds configurable components to a particular SkyPortal instance, for example, by use within a collaboration. And so today we're going to be highlighting a particular extension known as Fritz. And so Fritz is the SkyPortal extension used within the ZTF collaboration. And so if we just take a quick look at the SkyPortal GitHub page, I expect that many users are familiar with this page. This is where you create issues or open pull requests for the SkyPortal baseline app. And if we hop over here to Fritz, it actually looks quite similar to baseline SkyPortal. It has this extensions folder where, for example, you can add particular components that you need for your particular extension, or, for example, specific API endpoints that you may need to interact with the data that you have. And so going back to the main SkyPortal page, I built an instance that has some of these Fritz features enabled. And if we look on the left-hand side here in the dashboard, we'll see that there's two of them here. One is called alerts and one is for persistent sources, and we'll talk about each one in turn. So if we click on the alerts folder, we immediately see a table that has information like object ID, time, location. And so if we want to go ahead and fill this table in, we can do a cone search at a particular location on the sky. We'll make it a ½ degree to be sure that we get alerts within our table. And so you can see that the table is filled out here. So in addition to location and brightness information, you have information from the alert packet about kind of machine learning classifiers. And so if you click in the drop down, then you can see the thumbnails for the sources. And let's just go ahead and click on one of these objects here. And so when you click on this page, you get the full light curve, you get the thumbnails, you also get this table that has candidates, basically all of the observations for this particular object. You can click the Show Thumbnails button to change the thumbnail that's shown up above here. And we can go ahead and save this object as a source. We'll save it to a couple of programs in this case. And so you'll see that it's been saved. And so we can go ahead and hop over to the source page for this particular source. And bringing it up, we see the usual thumbnails, we see the photometry that we've saved, we see the source page that you'd expect to see for a source like this. Right, so that's how you save an alert source. And so if we go back to the dashboard and go to the left-hand side here, we can click on this Persistent Sources tab. And so the difference between these two, so alerts correspond to, in this case, 5 sigma excesses from some kind of transient, whereas persistent sources are, sources that are there all the time, usually things like variable stars. And so we can go ahead and take a look at an example of a variable source. I'm going to choose one that is of it's a particular favorite of mine, and we'll talk about that in a second. And so we'll input a particular set of source coordinates. And again, you see a table that has information like location, the filter, the magnitude. And again, in the dropdown, you can see some of the photometry that we have of the source. And if we want to save a source like this, we just click the sources on the side here. We can go ahead and click Save. We can save it to a few new programs. And so what this is going to do is this is going to take the various light curves that are saved in this particular source database. It's going to merge the filters together. It'll merge the observations on the primary grid and the secondary grid together. Within ZTF, we have two grids actually that we use to tile the sky to deal with things like chip gaps. And so if we go to our dashboard here, we've saved a source just a few seconds ago. Again, we can click on photometry, and we can see the source is present, as you would expect. And so this particular source happens to be a white dwarf binary that we found with ZTF a handful of years ago now. It's actually got a very short period, something like 6.9 minutes. And so it's very, very short here. If we phase fold it, we can actually see eclipses, and I'll post a link to it in the description. Well, that ends another SkyPortal how-to. We look forward to your thoughts, questions, and comments. And otherwise, we look forward to seeing you next time. Thanks.